basements are a huge concern for builders, homeowners, remodelers, and often the solutions are difficult and expensive. We all agree it's easier to get it right first, but there's some controversy on what that exactly means. So thank you all for being here. And we're going to talk about all these things and more in just a little bit. You guys have anything you want to talk about? We'll introduce ourselves in a little bit. So we'll wait on more folks get here. But anything you want to say about basements? Any big problems you've ever had with a basement? Oh, that sounds like a story.
I can talk about my own basement. When we planned, I have a walkout basement, so my backyard, my back of my basement is at grade level. And in March of 2010, we got a tremendous amount of rain, and the stream and the swamp, which are about, 400 yards behind my property or behind my house, filled up and up and up. So the water came in the door and then filled my basement up about a foot deep. And there was, at that point when you're flooded, there's nothing you can do about it.
Did your heating system get submerged?
One of the things that I learned many, many, many years ago when I was a young builder is all of the mechanical equipment that you put in a basement, always raise them a foot or two off of the floor. So I put down some concrete blocks, and I have a boiler and other tanks on top of those blocks so that I can get at least a foot and a half of water before any of the equipment gets damaged. And the same with all my outlets in my basement. They're all at chest level rather than down at ankle level. So if I can have up to a 3-foot flood in my basement and none of the wiring will be damaged and have to get ripped out, because anybody who's had this problem understands that when the electrical equipment gets wet, Romex wire, for instance, or non-metallic wire, you can't just turn it back on. You have to rip it out because the water will get in that jacket and it won't dry out.
Man, this just demonstrates the stakes of basement detailing, right, that we're going to talk about tonight. I think we should get started. If you folks are wandering in, you'll catch up. Lance, would you be kind enough to tell us who you are and what you do?
Sure. So my name is Lance Lang. I've been with UGL, United Gilsonite Laboratories, for 12 years. We are the makers of Drylock brand product and Czar brand product. Tonight is strictly a basement discussion, and we'll answer any questions you may have.
Cool. Mike, you want to go next?
What do you want me to do?
Why don't you introduce yourself? I mean, I could do it, but that's kind of silly.
Oh, no, that's fine. Mike Guertin, contractor / remodeler / occasional single family home builder in Rhode Island. And I've been writing articles for Fine Homebuilding for like 25 years. So, and I do a lot of these webinars, and they're really fun. Yeah.
Travis, can you please tell us about yourself and what you do in your company?
For sure. Yeah, my name is Travis Brungardt. I'm in Prairie Village, Kansas, which is 20 minutes outside of Kansas City. And I run a small residential remodeling and building company with my friend Joe Cook. I do a weekly show with GBA called BS and Beer that you might be familiar with. And then I'm also the local KC BS and Beer founder, partner, whatever you want to say about that. And I once got published in Fine Homebuilding, and I've written articles for years, but I've only been published once. So Mike's got me beat there. But it's a pleasure to be here with all of you. Thank you so much for the opportunity.
Well, I want to thank UGL, the maker of Drylock products, for the sponsorship tonight and for the help bringing this important information to you all. And I'd like to remind folks that UGL has been advising customers on the prep and application of Drylock masonry sealers for 12 years. Lance has been doing this for 12 years. Lance, what did folks most get wrong about installing things in their basement with regard to waterproofers?
What do they get wrong? Well, number one, they don't pay attention to gutters, grade, drainage properly. That's probably what, those are the questions we ask first. When someone calls and they say they have an existing home and there's an issue with water infiltration, and we find out that, they have serious leaks, it's generally a grade issue or a drainage issue.
And Lance segued us perfectly into the first part of our conversation, is that it's easy to get the details for a dry basement right from the start. It is way more difficult to fix things that are a problem later. I think you'd all agree. So I think most folks would say that a key line of defense with regard to keeping your basement dry are footing drains. Commonly, basement walls are either stacked masonry units or poured concrete on a wider footing. And the first thing that I would love to talk about is the pipe that commonly is installed as a footing drain. There's a lot of debate about where that goes. So does anyone want to weigh in and put their stake in the ground and say where you should put that footing drain? Go ahead. Go ahead, Mike.
Oh, you want me to put my stake in the ground?
Well,
yeah, sure. I'll do it. So I've done it both ways. In fact, I have photographs of me doing it both ways. I prefer to put them inside of the foundation. The reason I do that, or inside the foundation walls underneath the concrete slab, one of my main reasons for doing it that way is because I put down roughly a 4 to a 6 inch deep, maybe even 8 inch deep layer of crushed stone, 3/4, ½ inch across and beyond the perimeter of the foundation. So I already have a connection between the outside of the foundation and the underside of the foundation. But because I put the pipes on the inside, they also work as a soil gas depressurization system, otherwise commonly known as a radon mitigation system. So I can run a passive pipe up through the walls inside the house, and it do double duty with the drain pipe. So one goes out to daylight or into sump to drain any water that gets collected by that drain pipe inside the under the slab, and the other pipe will rise up to the attic out through the roof, and that will depressurize under the slab passively. And that there's some benefits to that, just primarily the radon, but also any soil moisture gets evacuated out that way as well, as opposed to the soil moisture migrating through the slab. So there's
Travis,
my stake.
Are you a believer on the inside the footing method, or are you on the outside?
Well, we always do the outside. The inside is actually in our market considered an upgrade. So the exterior drain tile around the perimeter of the footing is what I thought we were going to be discussing, whether you set it on top of the footing at the base of the wall, or if you set it down adjacent to the footing side.
Can you explain that a little to folks? So there's some debate about whether you put it at the bottom of the footing or the top, and what's the debate?
So I got torched on this live and in person by my friend Jake Bruton, who he got me to switch to his side. And yes, we now put the corrugated plastic pipe down at the side of the footing. So when you excavate for your basement foundation, you end up with the bottom of footing is your top grade of soil. By placing the footing drain at that location, you are at the lowest point, theoretically, that water would affect your assembly. Mm-hmm. So picking up the water at that location and draining it into a sump pump to discharge it and evacuate it away from your home, the common understanding apparently is that that is the place that you want to collect your water. The way that I had previously been doing it before this scintillating conversation last year was to put a perforated pipe on top of the footing at the base of the foundation wall, which is still basically in plane with the slab. You know, your interior basement slab sits on top of that footing as well. So I thought by capturing the water at that, basically that transition between top of footing and base of stem wall, that I was capturing the water that could be sheeting down the face of the foundation wall. I thought I was capturing it at the point where it was most likely to rapidly flow in and evacuating it below the level of the slab. So I still think that there is some merit to both systems. However, if you properly detailed that area with crushed stone and a sock to keep the crushed stone from being clogged with sediment. I do now agree with Jake that I go ahead and evacuate at the lowest point.
So I'm going to play devil's advocate to Mike here and say, shouldn't we be intercepting the water that's on the outside of the foundation before it gets to under the slab?
So your presumption there is that the water is coming from outside the foundation. In my area, most of the water is not coming from the outside of the foundation because of other water management details that I'm working to with an underground gutter diverter at grade level. What I'm most concerned about, because most of the houses that I build or remodel are set like so close to our water table, like within a foot, that it's usually rising groundwater that we're trying to intercept. And that water is going to be a fairly level plane under the house. So it doesn't really matter whether I catch it on the outside of the footing or the inside.
Do you think if you had, a steep slope dumping at the, back of your house, do you think it would be wise to put it on the outside?
Oh, yeah. In that case, I would probably do two. I would do one on the outside and one on the inside. Again, that inside one giving me that radon vent. So yeah, either way. Something, Patrick, we should mention too for folks who aren't familiar with this, who are listening to us, who aren't familiar with the big marker system, is that there are a few tabs that you can communicate with us on the chat and the Q&A. If you do have a question, probably best to use the Q&A, and that way we'll see it. We'll monitor that. And if you want to chat amongst yourselves, you could use the chat function there.
Oh my goodness. So we already have questions. So the 8-inch crushed stone is under the footing. So you don't need to add pipe to link the outside pipe to the outside pipe. So you already have a gravel bed there that is allowing that interior pipe to communicate with on the other side of the wall. Yeah.
Yeah. Thanks
for mentioning that, Mike. That is something I forgot, and I'm probably going to get fired for that oversight.
Don't worry. I'll talk to the boss.
You got more pull than I do, buddy. So I think you guys would all agree that one of the weak links in the assembly that we're all talking about with a foundation wall sitting on top of a footing is that joint there. What can we do about that joint? And the other thing I've heard problems with is a condition called rising damp, where soil moisture is moving through the footing into the concrete. You're laughing because this is something you've not heard?
No,
you think I'm making this up?
No, I've heard it. I think it's a really great term, the rising damp.
It's English sounding, right?
It is. I heard it first from my cousin-in-law, who's British.
Yeah.
And I'd never heard it before that.
So anyway, this is soil-borne moisture that's finding its way into the concrete or the masonry units and moving through them. So you need some way to stop that movement of water, which is on a molecular level. How do we do that?
So you're talking about the capillary action of the water that's being drawn through the footing, that's sitting like in water, and then being drawn further up into either the concrete block or a concrete foundation. Or
if you have a block wall, it often is constantly venting out the top of the wall itself, right?
Oh, the cavities and cavities themselves. Yep. Capillary breaks.
So I've seen on GBA folks like paint a coating on a footing. I mean, does anyone do that in the real world? You do.
Yep.
That's a detail for you, Mike.
Pardon me, Travis?
I said that's a detail just for you. I've never witnessed one in my entire career being executed on any home.
Have you heard of this, Lance?
I have actually. Yes, we did it. We did a project in St. Louis where we used our dry lock waterproofing on the top of the block wall as a capillary break between that and that first plate.
Okay.
Yeah.
So in that case, you used it sort of at the top of the foundation. Could you use it at the top? So if we pour a separate footing, say a 18-inch wide footing by say 8 inches or 10 inches tall, and then we put our foundation wall on top of the footing, a pure wall, you could call it, with that same, could you still use your product on top of that to form a capillary break between the
absolutely.
two? Oh,
absolutely. Shit. The only issue is, we need to wait 28 to 30 days for the concrete to cure before you apply our product. But 2 coats also. We recommend 2 coats. But yes, it absolutely works. It worked on this project over in St. Louis. Huge house, 10,000 square feet. I think it took about 5 gallons to cap all of the tops of those foundation walls. Now, they filled the block with concrete. So, we had something to coat, right?
Mm-hmm.
And it worked. It absolutely worked.
Yeah, I don't deny the efficacy of it. I'm saying in the field, you typically don't see it done.
No.
And I was referring to it at the top of the footing, bottom of wall condition,
Right.
so that you're stopping that rising damp from inhabiting the basement masonry walls. That location, top of footing, is where I have never seen it done. We always obviously use a capillary break at the top of wall. Usually we call it a sill gasket at that location. And so I would agree with you, Lance. It is a critical detail at that location where you're connecting wood to masonry.
Absolutely.
Referring to bottom of wall location. And that's where I haven't seen it done because it's very inconvenient to do for the reasons.
As you said, if you have to wait 28 days before you can pour your foundation walls, forget about it, right?
Right.
So I've used several of the people are probably familiar with them, used as a WRB, like a product they use trowel on or paint on. And we just use that same product. We wait like maybe 2 days and then we put it on because it's water-based. Put the foundation wall on. After it's cured, it only takes maybe 3 or 4 hours for it to harden up. And then we'll set our blocks or forms, and then we'll go up from there. And it's remarkable the amount of reduction of efflorescence that we notice on the inside of the concrete wall. Even though we do waterproofing on the outside, if we don't put that capillary break in there, in the lower foot of the foundation wall on the inside, the basement, we'll notice some efflorescence coming through if we don't put the capillary break on top of the footing. By putting the capillary break there, I've noticed on the last couple projects that we don't have that same efflorescence occurring. And when we put a moisture meter on it, it's showing much lower moisture at that point. And a piece of plastic works. We've also taken just some 6 mil poly and put that down on top of the footing. The liquid's a lot more convenient because if we have rebar sticking up, it's just a pain to get the plastic over it. Whereas the paint on, it only takes like an hour to do like 200 feet of footing with a roller really quick.
You guys want to kind of laugh here. So, if we go to the IRC for guidance, we had this conversation about where to put the footing drains. So section R405.1 of the 2018 IRC says, found drainage tiles, gravel, or crushed stone drains, perforated pipe, or other approved systems or materials shall be installed at or below the top of the footing or below the bottom of the slab. So there's no definitive answer. All those things are allowed. And I think it depends on your situation, which is the best, right?
Absolutely.
So I just learned many basement walls are not required, at least by the current IRC standards, to have waterproofing installed. Waterproofing is only required in areas to, quote, where a high water table or other severe soil water conditions are known to exist. What the heck? So you don't even have to do this, but I think you'd all agree that this is important stuff. It says waterproof materials accepted by the IRC include 2-ply hot mop felt. I bet you've seen that too, Travis, right? 55-pound roll roofing. Yes, of course. 6 mil polyvinyl chloride, 6 mil polyethylene, 40 mil polymer modified asphalt, 60 mil flexible polymer cement. I mean, so I think what we're really talking about, a damp proofing or waterproofing the exterior, is some kind of typically asphaltic coating. I bet more modern systems are acrylic. Do you guys want to talk about what you like to use, Travis and Mike, on the exterior of your foundation wall? Is that mechanism to keep soil-borne moisture from migrating into the concrete?
Yeah, my favorite product is the dimple mats. We've used a Dorkin product on the exterior. Most common in my market is just basic road tar on the exterior, called damp proofing. That's what I would say 90% of the houses I've ever built have had on it. I used to work for Production Builder before we started Catalyst, and I think we did 80 to 120 homes with them in my career, with none of the efflorescing condition that Mike was talking about and no capillary break. So it's possible that we were just fortunate. However, we did employ the interior drain tile on any of those builds that were in high water table areas. So we were kind of mitigating that problem in another way. The Guardian product, I think, is the name that we often use on the exterior now. And I think it's just a higher solids version of damp proofing. It's supposed to have some elastomeric properties, but that's what I have on the exterior of a large home I'm building out in the woods now. So we feel pretty confident in that system. But obviously, by managing the water before it's getting to that wall, you're mitigating most of your risk anyway. Mm-hmm. So that's been our experience. How about you, Mike?
As far as waterproofing, I've used both liquid applied foundation coatings, and I've used sheet applied. I also use a dimple mat, but I use that as sort of a cover sheet over the primary waterproofing. It's belt and suspenders, probably overkill, but most of the places where I work are, again, high water table. The soils aren't well drained, except when we backfill with clean gravel, but still the native soils aren't very good. So I've just gotten it's money well spent if there's ever the potential for future use of a basement. Everything we're talking about here comes down to if you want to use the basement or the crawl space to use as either dry storage or to finish the space. Essentially, you're working underground. So if you don't do everything you can to block the moisture, you have basically an unusable space. So when I'm building,
I would add, Mike, that even if you don't want to use your basement for anything, if it's contributing a moisture load to your house, that is a problem, right?
Yep, that's true. Good point.
Especially with mold risks and allergens and all those things that come with moisture, it is obviously best practice and really cheap insurance when you look at what it costs to solve it later if you do have infiltration.
I think that's a key point, Travis, is like it is always so much more expensive to do this correctly than try and go back and fix it, right? Lance mentioned right away in our webinar tonight that, roof overhangs, gutters that work, good grading, drainage, site drainage that works, in-ground gutters. We'll talk a little bit about, have you guys seen problems that are easily remedied by just fixing some little things? Do you want to talk about that, Travis?
Oh, I'd be happy to. Most of the basement projects that we get called into here in Kansas City are, I would say 90% of them we solve with exterior gutters and grading. Clean gutters and 6 inches of positive drainage in the first 10 feet away from the foundation solves 90% of what we're working with. And that last 10% is problematic site. The neighbor has installed their sump pump discharge to the side of their property, dumping directly above grade.
Have you seen this really?
Many times. It's exhausting. And you always feel bad because,
there's no fix.
Well, you have to go to the neighbor and say, we would like to resolve the problem that you've created by attaching a pipe to the pipe that you have placed that's dumping water.
And do you aim it back at their house? Is that how that
works? Water
wars. Yeah, we put an exterior right there and then pipe it into their, no. We actually had to do about 48 feet of French drain work to resolve that just last year on a site in Prairie Village. And it was at my client's expense. It was basically a ground gutter like Mike's describing. We created a swale, filled it with, put a French drain in it, and then discharged it to daylight behind the house rather than into the basement. But yeah, it kind of derailed the nice project that the clients wanted to do because they had to do thousands of exterior work to make the basement usable in the first place. So anything that you can do to keep that drainage from running into your property is the first line of defense, and good grading is almost always the easiest. But the ground gutters that Mike was talking about earlier, I think that's an excellent solution to help basically route the water away from the foundation. How do you detail those, Mike? Are you using poly below grade, or do you use something more substantial?
For the underground gutter, I use EPDM, which is probably way overkill. I salvage whenever we do a re-roof on with a membrane roof, where we take the old EPDM or the old PVC off, instead of throwing that stuff away, I'll salvage it, and it works great because it's something that's going to go in the dump anyway. So we just put it underground as gutters. If it's got a little couple of holes in it, it isn't going to matter. So recycle it that way.
Somebody just said, guys, please don't neglect to address different strategies for mitigating foundation issues and water problems in older existing homes with masonry foundation. And we're working there. It's yeah, and that's a big problem, right? I've never lived in a house that didn't have water come in the basement at least once. I never lived anywhere like that.
So where was the water coming in that you in the places? Was it coming through the floor or through the wall?
Yeah, so I in one case had rising groundwater, and it came up in cracks between the slab and the foundation wall. I've had water come in around my bulkhead door, right? Because obviously that's a weak spot. And then I've had other situations where it was seemingly a very typical storm, but water would come in from some random place. And my guess is that's groundwater too, but I don't really know. What do we do about these things?
And when you saw water coming in some case, you mentioned the joint between the slab and the foundation. If it comes in through the wall, was it coming in through cracks or was it coming right through the concrete?
I think it was the crack between the concrete slab and the concrete block wall, right? Because no one ever details that correctly, right? It's just poured right there and the concrete shrinks and pulls away and then they put tile over it. No one caulks it, you know. It was funny. I got up in the middle of the night and stepped in like, you know, a quarter of an inch of water, which is a very alarming occurrence. If you've never had that happen, you can imagine.
The stuff of nightmares.
And in each of the cases is going to be a different solution, right? So at that joint between the slab and the foundation, usually what I'll do for that is, because I've never found any sealant that will block that rising groundwater, because there's so much pressure there of that groundwater. I mean, you're basically in a leaking boat at that point. The groundwater is above your slab level and it wants to get in. So the only thing I found effective there is actually cutting the slab out around the perimeter, setting a drain up, and then running that to either daylight, which is usually not practical, or to a sump pump. And I've done retrofits on houses where those sump pumps are running, you know, come the February, March, you know, when we get the melt in New England of the snow, and then all of a sudden the groundwater rises. And for like a month or two, those pumps will be running on a regular basis just to evacuate that water. And it does work. You know, it
comes with an energy penalty, and you got to remember though, like when you get lots of rain and storms, that's when your power goes out, and you know,
that's battery backup.
You got to have battery backup. And I've seen these other systems that run on water pressure that use city water pressure to power a pump. You know, it's Lance. So, what do we do about this?
So, as long as that area doesn't exceed 4 psi, we have a waterproofing, a clear waterproofing for the floor, for the slab. But then we also recommend using our fast plug, our hydraulic cement, for that area where the slab meets the wall.
And how do you have to grind that out? Can you just put that in?
Yeah, you know, in most cases you can grind out, back it out 1/4 inch or 3/8, and then fill that with the hydraulic cement. That comes in powder form. You mix it with water. And
you have to work fast. I think you'd agree.
Work extremely fast, but it will. Again, it all depends on the severity. Mike's right about channeling out situations where the pressure is just too high. But we are clear for the floors. We make at a 4 psi because we know the slab will break above that. But
so you don't mean the slab will break. You mean that the coating will stick to pieces of concrete, right, and spall off?
We initially made that product to withstand more psi than that. But what we found was the concrete slab would crack. A weak point would crack, and so 4 psi will control most of what we've seen. If it's more severe than that, then you have to do what Mike is talking about. But in most cases, the hydraulic cement along the edge works, and using the clear on the floor.
How would we measure if we have a 4 psi difference? In other words, if I've got water coming in my basement, and I know that if it's less than 4 psi, like you say, that these products would work, but I wouldn't know how to know if I've got more or less than 4 psi. Is there
Yeah,
any
I mean,
kind of like a quick and easy way of determining that?
honestly, Mike, I don't know. I've not seen where there's a situation where the floor and wall, the clear, doesn't work. I've not witnessed anything above that 4 psi. From what I understand, from what the labs tell us, is that the slab itself, the pressure, the weak point of the slab, there will be a weak point found, and it will crack, both, somewhere north of 4 psi. And so we didn't want to seal a slab and it withstand higher than that, and then we cause slabs to crack.
And I've seen like moisture or water evidence through efflorescence, and it's hard to know, maybe I'm wrong, if it's liquid water or vapor movement. I'm not sure that vapor leaves behind the trail of efflorescence that I see in my basement, but what do we do about that, gentlemen? Like, how do I fix that? I'm not going to dig up my foundation wall on the outside, right? So are there things I can do to slow that water from getting in my basement?
I know you can clean it off and then you can seal it. I mean, that's what we've done when we've done finished basements in the past, and how I kind of became familiar with the UGL product of dry lock was basically you dry it. Usually we would just use indoor dehumidifiers and fans running a couple days to lower that ambient humidity to where there wasn't actually moisture in the wall. And then frequently we were dealing with more mold issues than efflorescence, but we would do % bleach mixture and clean everything off before we started drying it so that it was scrubbed clean and ready to accept paint. Then we would dry the area over a couple of days, and then we would roll on the dry lock. In fact, I'm coming to you live from my basement in Perryville, no in the city, built before 1950, but this basement has CMU wall foundation, foundation wall. And I did this process here because we have 3 leaky corners. And then I followed it up with Andy Engel wrote an article for FHB years ago about a dry basement system that basically involved laying up sheets of foam on the walls and then building it up as well on the floor, and then doing a floating floor above that. And the floor already had a drain, so any water that's getting in, I don't know about it because it's traveling below that membrane and out to the drain. But I have an unfinished portion of my basement, my shop and my laundry facility, and we've got white dry lock on that I put up 15 years ago that has held all of my front drainage at bay. Basically those shortcomings when I don't stay on top of the gutters.
Yeah.
We still have occasional infiltration at other locations that I can access. And this front side of the house is held up just fine where it's exposed. An old drip trail across the floor to the drain. So I know it's coming in somewhere, but I have a mold allergy. So this would not be a good place for me to hang out if it wasn't working as planned. So that's been our solution. And after having success at my personal home, I felt confident doing it on basement after basement after basement. I bet we've done 20 or 30 just in this market over the last decade.
It doesn't cost a lot, right?
Rolling up gallons. My friend Isaac, who works for Watson Construction locally, he does it as part of his standard practice too. And he's constantly telling me how efficient, because you're able to move forward with your project the next day. So if you compare slot cutting the perimeter, installing a curtain drain, like all these other alternatives that are a means to, mitigate that risk versus loading up your paint tray and going to town after one day of prep and cleaning, he's framing day 3 and off to the races. So it's a very effective solution for us.
Mike, Travis, Lance, so one of the things that happens in basements is you get shrinkage cracks in foundation walls or concrete slabs in the floor. Like, are there any reliable solutions to prevent water from coming in those cracks when we have high water table events? Or weird groundwater movement?
Epoxy
We
injection.
recommend. What's that?
We've always had to do epoxy injection. If we actually have cracks that are letting water in vertically, we've always had to drill them out and inject epoxy to solve that. But shrinkage cracks are much smaller. You were going to say, Lance?
I was just going to say a shrinkage crack is much smaller, and it could be ground out too to maybe 1/8 of an inch. And again, the fast plug, the hydraulic cement works really well. I've
What the
actually
heck
used
is-
it on water coming in and literally stopped it.
I've heard of that. What the heck is hydraulic cement chemically? What is going on there?
I can tell you this: when you mix a little bit of water with this powder, it heats up. You don't want to be holding it. I do these demonstrations with a lot of the hardware younger crowd. I'll mix up a little bit in a cup and I'll dump it out onto the table, onto a paper towel. And within about 3 minutes, it's rock hard. And so I'll reach down and grab it and toss it to somebody in the front row. And they're always surprised, because it's set up. But it heats up and expands and becomes part of that substrate, and it stops the water.
Well, you said it's expansion, Mike.
Yeah, it does expand, and I've used it to fill the joint between soil pipes or drain pipes that go out through the concrete wall.
Because it's never a tight fit, right? The plumber is always drilling the hole oversized, or the contractor, the concrete guy.
Yeah, so we'll hollow that out and we'll inject the hydraulic cement in there, and then we'll, hold it back till it cures. And that's just, I've done them in many houses where the leak was persistent year after year, and only after we chiseled it out, created a keyway inside the foundation or in the concrete wall of the block, and then filled it, and then it just stopped. So it does work great.
I'm going to tell you, I mentioned the basement water infiltration episode where I woke up and stepped in, a half an inch of water and was walking through the same water to go to the bathroom before I could turn on the lights and figure out what the heck was going on. So my solution to this was to completely excavate the outside of my home and completely backfill with gravel, installing a new footing drain. And obviously that's not practical in every solution, but I mean, was I lucky that I never had another incident? Was it just randomness, or did that actually help the situation? Because it seems unlikely that I excavated all the way to the very bottom of the footing to put the drain. I kind of feel like I stopped at the top of the footing. So was I just lucky, or was that increased capillary space in the gravel versus clayey soil? Would that help?
Every house is an experiment, and everything you do to a house is an experiment. And the only way you're going to know is to set up a control. So unless you want to set up a control, you can't answer that question.
And my house was little. It wasn't that much gravel. It was, a couple truckloads, but it was a lot of work, as you might imagine. And that's not a practical solution for most people.
Yeah, but you got to rent a machine and play with it. For
I got a
days,
couple.
okay.
Like I got to rent an excavator and a skid steer loader. Oh, it was fantastic.
Yeah.
And I was in my 20s, so I didn't care.
Unless you're solving for groundwater, spring fed and below, like Mike's dealing with his high water table events, you really are solving in our experience, you're solving most of your problems in the top few inches, not even the top few feet. So the fact that you dug at all means you made a significant improvement in managing all surface water coming toward your home. And then when you think about, water moving across the top of the rock, the water table that we're dealing with, as long as your home is inches above that water table, you really should never have any infiltration as a result of it in what we've experienced.
What's your soil type like, Travis? Is it gravel, sandy, or is it clay?
We have a lot of fatty clays here. We have a lot of very successful piering companies that work in our neck of the woods.
Because of failed foundations?
Yes.
Oh.
Yeah. Neighborhood was built, as I said, in the 50s with concrete masonry units. So the so-called cinder block foundation walls are throughout my community, and they're just not good at resisting soil pressures laterally. So those fatty clays get moisture, they swell up, and all of a sudden you've got a 3-inch bow in the middle of that wall. Or like my lumber salesman up the street, he, I think, had his mud sill sitting 2.5 inches cantilevered off the side of his top of wall.
Because the wall was pushed in?
Yeah.
Wow.
So we really have problematic soils from that. We don't have any sandy stuff around here, and there is some rock and a lot of springs in certain areas, but not in my neighborhood.
If you guys are faced with just like an impossible building site, with a large slope draining onto where the house is going to be, like, are there things you can do either with coatings or French drains on the lot that can deal with these problems that are very difficult to solve? You can't level the mountain behind your house, right?
No, you create a new lower place that isn't your foundation away from your foundation. A natural French drain or dry creek bed look with a French drain below it is how we usually solve that. So you have to integrate it into the landscape and create a better path for the surface water to drain away. Anything on below grade stuff, we've had 4 and 5 sump backup systems, 2 inside, 3 exterior sumps. I mean, there are a lot of ways to throw money at it to solve it, but I always say the best way is the no maintenance way. So you solve it with grade first, and that's been our method.
What do you think, Lance?
I agree with him. Absolutely. If you can redirect the water on the exterior, I mean, you're 90% there. He's talking about damages though too. I mean, something has to be done with those walls that are bowing. I mean, that's a tear out and a redo, right?
Unless the piering guy is going to, support the house independent of the wall, I guess, but you still need to resist the soil pressure to keep it from caving in the basement, right?
Exactly. So excavating is the only thing you can do in that case.
What's your soil type like, Lance? Do you have problems with clay soils?
So yeah, I'm in the Midwest, and it is more clay-like. It's probably very similar to Travis. Yeah, and we have the same group of guys, peer guys, that they stay pretty busy. We have subsidence issues too, where they've had mining that's taken place, and I mean, not in our neighborhood or not anywhere near where I live, but that has been an issue, subsidence.
We were talking ahead of the program that the COVID outbreak has meant folks are using their basements and for schooling their kids, or Travis was saying that that's your office. I don't know if that's normal or if that's a result of the outbreak, but what advice do all of you folks have for people who are trying to make their basement space more functional, drier, healthier, so they're not putting a lot of moisture in their house? Travis, why don't you go first, if you don't mind? I saw you just turned off your mic, but
I'm happy to go first. I think that we have 2 different approaches. If you have a partially finished basement that already has moisture issues, that's one set of solutions. If this is a starting point and you need that found space to make your home office work, or a home gym, or even just an entertaining space to get away, the starting point is always the same: clean and dry. So usually for our clients, we'll tell them, we got to get your stuff out of here to see what we're working with, because it's always, the Christmas tree, the kids' clothes that they outgrew 30 years ago, every assignment mom saved, all that stuff has to go so you can see what you're working with. Once you have it truly clean and you can see what you're up against, then we always start with, let's plan for the worst. Even if it's never been wet, the least we can do is put up a dry lock coating to solve any moisture that would get into our wall system. Let's plan for a floating floor, because none of the slabs in my area have any insulation under them. An insulated slab is a luxury. To make that basement a comfortable space, we're usually insulating the floor, and then the floating floor above that, the framed walls within that area, we're essentially ready to start to make it a comfortable finished space. If you have a problem that's existing, we usually look first to solve that from the exterior, and then it's the same steps on the interior.
Who wants to go next?
I'll go next. Let me just say that when someone contacts me and says that they have a wet basement or a damp basement, and I need to find out how damp, right? So putting 4 mil plastic in areas of concern, taping those down with duct tape, or using a rubber mat to find out just how much moisture comes through that surface is number one. And if we find out that it's discolored, it's not really, there's really not much moisture there on the surface, then we know how to handle that. But if it's really severe, then we have to refer them to guys like Mike or Travis to do other things. But 90% of the time, waterproofing the walls, waterproofing the floor, repairing cracks, it works. Our product is tintable, so if someone prefers a different color other than white or gray, we can make light to medium shades. It's pretty versatile. And
so instead of your improvised office being bare concrete, now it actually looks like a painted wall to your coworkers, right? It's just like
Absolutely.
This is
Absolutely. Yeah, and not a lot of people know that it can be tinted. We can make a number of colors. It's easily done.
We got a good question here. I'm going to jump into it. What, if anything, can be done with a pre-1900s brick over fieldstone? I've been told these need vapor movement through the brick to let the lime mortar self-heal. Yeah, some efflorescence can repoint. I don't know whether that will do the job. Anyone want to take a stab at that? That's a hard thing, right? Those walls are super porous.
That's a mic problem. I don't.
The only thing that I couldn't hear what Travis said. When I've approached those old foundations that are, brick or block or stone or a combination of those, whether with lime mortar or even just regular Portland cement mortar, where we're getting a lot of moisture in, because of the concern about particularly old clay bricks, we get a lot of those here. And if you start playing around with the inside and sealing them, we end up without that moisture transfer and have had problems where we just increase the spalling and breaking up and crumbling. So just bite the bullet, excavate on the outside, and then waterproof it from the outside. And we just
I've excavated fieldstone walls, and it seems like at any time they could collapse, right? It's kind of a dodgy exercise.
Sure.
Yeah.
So
you just got to be careful because you can push them in.
It's not something. Right? It's not a DIY project.
No.
There's something to be said for working in sections and limiting that risk.
Mm-hmm.
If you dig out the entire, side of a house, yeah, you've really taken away all the support that the soil is offering that wall. But if you isolate your excavation to a 4 or 6 foot area, you're really limiting that. If you think about it in terms of like a window header that's carrying the entire second floor loaded roof with a couple of 2x10s, yeah, that's a reasonable span. That's a good way to dig out, address, then put gravel and backfill. The problem is it's nearly impossible to roll out drain tile in that space and then mate it up without creating other issues. So it makes it very slow and challenging, but it is safer to do it that way.
There is a detail that Building Science Corporation did on several projects when they were trying to figure out with the old rubble wall foundations what could be done. And what they had figured out was putting a membrane on the inside, which usually you wouldn't want to put plastic inside a foundation before you finish it because it can cause all sorts of other problems. But they put a membrane on the inside. They ran that down to, and they had a channel cut where water could drain down below the slab. Then they put high density spray foam over the top of that. Same on the floor. They put a mat down and then they put high density spray foam over that. So they basically encapsulated the whole inside of the foundation with spray foam. And then they built in from that face. That way water could come through the foundation. It would all be drained down below the slab, managed there. And then the inside was completely impermeable, separated from the outside. Very expensive, but they found that it were very effective on homes in the test cases that they did.
And I think having a flood event is more expensive than fixing, doing that kind of work ahead of the occupancy. Yeah. I wanted to mention that Lance brought some handout sheets along with him, and those are available for participants here. They have some details on some of the products and some methods to manage water in your basement or foundation area. So,
and how would people find those?
They click on the handout button.
Yes.
There they are.
Yep.
2 PDFs and a doc.
Let's see if we have time for one more question here. Do you use dry lock on the interior of the wall if there's no vapor barrier on the outside? And the answer is yes, right, Lance?
Absolutely.
Yeah.
Yep. Every day.
When framing out a basement, should you put 6 mil over the concrete before framing? Some kind of capillary break, but not that, right? Like sill seal, right?
I think they're talking about you've got a basement wall. Should you put 6 mil poly over the basement wall before you frame the wall?
Oh no.
Or they could be talking about the slab.
That's what I thought, but I could be wrong about that.
Yeah.
Edward, what are you talking about? Where are you putting
the answer? No, right?
No.
So regardless, no. We use treated sill plate when we do basements. I've done metal stud framing in basements for durability reasons that I think is a poor use of metal. But we don't even do if you have that much water moving through your assembly, you really need to make a more concerted effort to solve that before you start framing it in and finishing it.
Basements were never really intended for living space. That's one thing people have to realize. They're really just a way to get, look at my grandparents' house. It was where they stored the summer's crop of root vegetables. It was like a root cellar, basically. So in some cases, there is not going to be a really good solution for some of the problems to turn a basement into living space. There are limits to what we can do managing water.
I would feel foolish to disagree with the national treasure that is Mike Guertin, but I'm going to disagree with you anyway.
Okay, good.
We finish a ton of basements based in our market. I think that one of the things that you miss, we started with caveman, right? Like before we had the house, like we're okay to live underground. We just have to do a few things to make it work. And I think the main thing is to manage the dampness. We try to use vapor tolerant materials because a lot of times there is going to be some humidity, or you completely solve for water, which Lance can help you with. And then you don't have that comfort or air quality issue in the first place. But to be fair to Mike, your market's full of fieldstone and springs that I don't have to deal with. So, different conditions, different strokes for different folks. But we definitely, we have a lot of, guest rooms in basements, frequent use spaces, but yeah, probably not your master suite in the basement, probably not the kitchen, but certainly my family watches Friday night movie down here in our basement. We love it.
That's cool. And it's nice to have a space that is reserved for something special, right? It's like you go there to do this thing. Either you're working on your craft or you're exercising or you want some quiet or you want to have family movie night. It's cool to have that kind of space. And it's hard to argue that a basement is not perfect for that in many cases. Andrew wants to know, is there any benefit to installing perforated pipe horizontally across the basement every 8 to 10 feet in addition to along the perimeter? We are in a high water table area with clay soil. I'd say, Andrew, if you're in a high water table area, that's not a bad idea. It's not a lot of money and it's going to be hard to do later, right?
Well, if you're going to be building new, then rather than just putting those pipes in, if you put a layer of
gravel,
stone or drainable gravel, the water's pretty much going to level out through that. So you wouldn't necessarily need a lot of pipes. If you don't have a gravel layer or a stone layer underneath, then the additional pipes would be helpful just to collect the water that's unevenly distributed under the slab. And then, of course, always with new construction, if you get the opportunity, the code does require, I think the code does require that under concrete slabs, we put down a minimum of 6 mil poly before we pour the concrete slab. So that's going
and your
to
contractor, your concrete guy is not going to want to do that, but you have to make them, and you have to make sure that they don't put a bunch of holes in it, because that is a very difficult thing to get them to want to do.
And don't put a blotter layer of sand on it. The concrete should be in direct contact with that plastic to be most.
And the
most
plastic should be over the insulation layer, which is a mistake I made in my barn build. So don't do what I did.
I'm impressed that you have an insulated slab in your barn. That's a big win, Patrick.
It's really hard to put it in there afterward, Travis, right? You have to do it. And it makes your concrete take a long time to set up, to tool it, trowel it. So that's why the cement concrete finishers don't like it. Lance, I'm going to let you go first. What's your parting words for our folks who are here tonight?
Well, hey, we appreciate everyone attending and your interest in keeping a basement dry. I'm in company. The guys that are on this webinar are very intelligent. They know what they're doing. I appreciate being part of it. I truly do. Travis. So, hey, we're grateful for the opportunity, and we try to offer solutions, and I think we do a pretty terrific job.
Thanks for being on the show, man. Mike, what do you want to say?
Nothing to add. I think, there are a lot of articles in Fine Homebuilding and on the Green Building Advisor about managing water in basements, about how to do footing drains and how to do them inside, how to do them outside, all sorts of stuff. So is there a way that you were going to couple some of those resources, Patrick, so that people could find those?
Yeah, I'll put your
how
slides with the page, or ask Jess to, and that we have some detailed photographs that you've taken, and we'll link some other stuff too.
Yeah. So if people go and watch this after the recording, there should be a notes page that they'll see all the links to those articles.
That's correct.
Yep. Okay, good.
Travis, what do you want to say before we part company?
Well, if you can't get a hold of the details from Patrick, just send me $5 and I'll send you the sketch I made while I was.
Oh yeah, you don't have to send me any money, and I'll send you all my sketches because I'm working on.
I don't have any sketches.
Foundation details.
Oh man, we're shoot out on that too.
Yeah, right.
Well,
no, I guess the only parting information I would give is that if you want to learn more from people like Mike, you should come to Kansas City in September on the 28th and 29th for this year's Building Science Symposium. Mike will tell you everything you need to know. So come to that, read Fine Homebuilding, pay attention when people talk, and you'll do fine.
Well, I want to thank everyone for being here, and I hope it was helpful. I learned some stuff, and it is always a pleasure hanging out with my friends at Fine Homebuilding. So I hope you all had a good evening. Please stay safe, keep craft alive, and keep your basements dry.
So long.
Thank you.
Bye, everybody. Thank you.